Okay, so we've done a lot of work just to get set up, and I realize that it's a little bit tedious, but we're really ready to now move into actually using Dynashape to look at the deflection of our structure. We still have a few hurdles to go through, so be patient. The first thing we need to do is actually let's just look at what our goal is here. I'm going to open up the solver. And the solver that we're going to use, the one that's going to visualize our deflections and our stresses, is to execute silently. And I double hit it. Let me delete one. But the important thing to note here is there's a lot of inputs, and we've got to satisfy at least the goals, the goal geometry binders, the reiterations, and this terminal threshold. So what we've got to do is actually find these goals and get those set up right away. So we're going to do that by going to our goals. And there are a few goals that we want to create. We want an anchor goal, and we want to create one. That's going to be our base positions. We have a length goal. Let's see if I can find it here. You can see there's a lot of them. And it opens up the opportunity for realizing how many functions are actually available here. Anchor goal, we want a length. I'm not finding this listed. Let me just type it in. Goals dot length. Oh, it's called a length goal. I'm sorry, I got a length goal. That's for our elements. And then we have the other one, which is the loads that we're going to apply to it. And those are called constant goals. So we want to create a constant goal. Oops, and I managed to do 3 of them here. Okay, so our goal for anchoring is really our supports. So let's go up and find our supports here. So we have our truss supports, and they were coming out as these 2 points here, the 2 that we gathered up. So we'll go ahead and put those in as our start positions, and we'll put them in as our anchors. And they're going to need to be fed a weight. Did I say load? I meant our base points, or where our loads are being applied to, our supports, should I say. We're going to need to apply a weight. Anyway, we're going to need to apply a weight to it. So I'm going to grab a code block so we can put a number in. And we want this number to be very high. The idea is that this solver works for all kinds of different conditions. So we want this to be inordinately large, so it looks like it has no give to it at all in order to make this thing function properly. And that's just from other training tutorials I've seen and discussions about this. Okay, the other thing we need are all of the lines, the length goals to connect to all the nodes. And we're going to need to do a list create for that because we're going to have to bring in a bunch of the elements. So I'm going to grab, oops, sorry. And really, we've created 4 different kinds. We've got all the bottom lines, the diagonal lines, the top lines, and the vertical lines of the truss element. So we have 4 items we want to bring together into a list to create our lines. And this is length goals, length create, and it has start position and end position, and that's not quite correct. This is a wrong goal. I'm going to try to look for the other one. I want to find another length goal here. That's the one I want. Excuse me. I'll just delete that and change that to the one that only has a line and then a target length that we're going to put into it, which is really, well, I'll describe that in a second. Okay, so let's grab all of those lines and put them together in a list. So we have all of our, we have them all in previously created. We just got to gather them all up. And we kind of left out a little bit about our segments by not combining these. So we have, these are individual sets of lines. So we need to do a list create for those. And I'll do a bunch of these. Sorry I didn't do this before. I'm going to copy this down because each one of these we have multiple lists for. Well, the vertical members we don't, but these we do. And then we're just going to tie those into a mega list. And it gives us list of list. We might want to think about flattening that. So let's pull that back and flatten. Now we have a list of all the points. We'll clean this up in a minute. So I'm going to feed that into our lines. And our target length is actually kind of cryptic here. It's really just the length of that line turned into a curve. So we have a curve, or excuse me, the length of that line defined as its length. The length of that line defined as that line defined as just its length. So we're going to do curved length, curve.length. Whoops, I don't know what happened there. And so we're getting the lengths of each one of the elements that's fed into the target length. And then I'm going to use a code block again. I'll just copy this one over. And let me just zoom in here a little bit closer. And we'll make this one, we'll set this value for 50,000. These are just numbers that helps the this node actually operate in a reasonable range. Okay, so the last thing we have to do is the actual loads that are going to be applied. And we know that those were, we calculated those already. Let me just confirm on my other sheet here where they're coming from. Those are those top nodes. So it's the geometry intersect. I think we're going to need to flatten it. So, but for now, I'm just going to stick it right away into, just to hold it here while I get our flattening control. So that's 5 points. We actually want 6 points, so I grabbed the wrong thing. It's probably this list create one, sorry. And once again, I did the same silly thing with double flattening it. So now we have all those top points. And those are all of our start positions for our loads. We need a vector, a constant, in a direction with a value to it. So we're going to do a vector by a coordinate. And we're going to do a code block to give a number. And this is a in the opposite direction of the other load. So we want that vector to go in a negative direction. So we're going to put a -1 in there. We'll feed that into the z direction, and that is our constant. And then we're going to create a slider for adding weight. And we'll make that go from 1 to 100 in steps of 1. Okay, so just to step off for a minute and look at what we've done. I've gathered up all the two anchor points, all of the truss elements, and the 7 loads that are applied to it. And I don't know why those aren't showing there. Makes me think I have an error. Okay, we'll let that go for a second to see if I've actually introduced some sort of an error there. It's a flattened list. Okay, so we have that set up. Now what we want to do is we're going to bring those all together, again in a list, so we can set those up as the goals. List create, because the software can separate out those different values, so we can feed those 3 values in. So we have our 2 loads, and you'll notice they're already labeled as what they are. Let me pin that a minute, and let's look down here, and we have this. This is where I think our problem's coming in right now, and I'm going to have to troubleshoot that. Why we don't have start positions. And weight, but we don't have anything coming out of that correctly yet. So we'll go ahead and flatten that list down because each one has its own unique identifier. So we'll go in. There's no need that we need a hierarchy to our list. And I'll unpin this, so this will go away for a while. And now we need to just fill in 2 more things, the iterations and the terminal threshold. So let's go ahead and use a code block to do that. And this is just writing code that I was given to set this up. So it's / iterations, defining it basically. And we'll make that 10,000. And then we have this terminal threshold. (1.0e to the 10th power). And we'll feed those in. And we actually should see this starting to run now. So let's see if, and like I said, I've got a problem in here. I'm going to cut the tape and find out, try to diagnose what I've done wrong with this, why I'm not getting goals coming out of this one. And that should solve the functioning of that. So we'll pick that up after I've diagnosed what I've done wrong.